Now to enter, to make a scatter plot on a TI-84, you'd enter these two things in. So find your list. You've done that before. You entered the two variables into list 1 and list 2. Okay, I've done those two things. Then you go to your statistical plot. So you go second y equals, that gets you to your stat plots. You go from off to on. So you toggle over to on and you press enter so it goes to on. Right here's the on. Then you go down to the first default is scatter plots. The X and Y list, if you've entered it into L1 and L2, then the defaults are okay. And this mark just means that it's going to be a little box mark instead of these two little smaller dots here. Okay, to change a list, like let's say that you entered into list 3, remember you say second and then you press the numbers 1 through 6 to get to your lists. Okay, and then before you graph it, you want to go to your window, and actually this right here shows you how to change your X min and your X max based on your data. So here by default it's -10 to 10 on both X min, X max, Y min, and Y max, but our data set doesn't have any negative values for X and Y, so I changed it to 0 and 11. So the highest homework done was 10, so I went to 11. And I went from 0 on the X min to 110 on the X max because the highest highest test score was 100. A quick way to also do this is to hit stat, or to hit zoom stat. So this is zoom, to go to the zoom and hit the number 9, which brings you to zoom. 9 is the stat option, and usually it will get you a nice window value based on your data in your list, or the plots that you set up in your stat plot actually. So hit graph, and you will see a scatter plot. So this is the scatter plot that we made at the beginning of the lesson. Okay, if you create a regression line on the graphing calculator, what you do is you want to go into, you put the list into, okay, so you put the data set. Let's say that we go back to this data set, and I'm gonna put those in my calculator. I put this into L1 and L2. My X list is in L1, my Y list is in L2. If you put them in a different list, then you're gonna have to just be careful when you get to this stage right down here. Then what you do is you hit stat and you arrow to the right, you go to calculate, and you want to choose this option 4. You want to calculate a linear regression. So you can either press 4 or you can arrow down to 4 and press enter. Now if you're operating with if you have the newest operating system on your TI-84, then it's going to look like this. It used to sort of look like a line that was on your home screen. Now it gives you, it's a little easier to see. So linear regression, you know that because it says it up here. Your X list, I pulled it in from L1, my Y list was L2. Remember, you can always change this if you use second and then the number keys, and you can input like L3 and L4 if that's where you have it. Now this right here, the frequency list, we're not going to use that because every number in our data set is entered exactly once. So let's say that you have a bunch of numbers like 2, 500, and you have another 2, 500 in your data set, right? Well, you might have a list, you might have this in your X list, this as a Y list, and you might want to just enter it in once. So you might have a frequency list that shows a 2 in a column for this point, meaning this point is represented twice in your data set. Now that's for a more complicated data set. We don't have something like that. So our frequency list, we're just going to ignore that and arrow down to store regression. Now if you hit alpha and trace, you're going to be able to store the linear regression into an equation that you have on your calculator. So let me show you. You go to stat, go over to calculate. I've already entered these things in. I choose option 4. I press enter here. L1 and L2 is already in. Arrow down to store regression, alpha, trace. That's going to get me, that's my keys for all of my equations that are in the y equals. So if I go to the y equals menu, I actually already have it in there. So these are y1 to y7. So if I do that, then it's going to store it as a line there. It's going to just input it there. So alpha, trace, I choose option 1, and I go down and I hit calculate. Okay, and you're going to see what I have on the screen here. So what this is it gives you an A value right here. Let me show it. It gives you an A value that is your slope. Now it happens to be a very, very small slope because our data set was very strange. Our X value started at, I think they started at, let's go into our list here. They started at 15,000, where our y values only started at 60. Um, or actually they started at 55%. So there's a very big difference between our x and y list. That's why our slope is very strange, and we'll interpret it in just a second. And it gives you the y intercept. So getting back this equation here, it gives you the y-intercept of 53.64. So let's go ahead and interpret these things here. So this right here, remember this is in scientific notation. So this is really like 4.6, or I estimate it at 5 times 10 to the negative 4. That means working backwards from 5, I've got to move 4 spaces to the left. 4 spaces to the left means that I have 3 zeros between the numeral and the decimal here. So that's my slope. Now, what that interprets as is, it says that for every, remember, slope is rise over run, so it's change in y, delta y over delta x, change in x. So remember, y is the percent ownership, and x is the income, right? So it says for every $1 increase in income, there's a 0.005% increase in car ownership. Okay, so it's for every dollar increase in income. Now it's so strange because our increases of income were by 10,000, or I think it was maybe by 5,000 or 10,000, right? So if we just look at the unit rate, which is the dollar increase, it doesn't make any sense. You could interpret this a little bit better by saying for just multiplying this fraction by 1,000 over 1,000. So you'd get 1,000 in the numerator and 5 in, sorry, 1,000 in the denominator and 5 in the numerator. That means for every $1,000, there's a 5% change in car ownership. Okay, so that's like a little bit more meaningful. Now with statistics, again, it's interpretive. So the way that you interpret the data is really, really important in how someone understands what you're saying. So making a choice to report it this way might be a little bit better than to report it the way that it shows up on your equation here. Another way of saying it is, so we often refer to the change in x first and then the change in y. The y-intercept, the way that this is interpreted, remember the y-intercept is the y value when x is 0, right? So it means that when income is 0, because that's our x, the percent ownership is 53.65. Now you've got to be really careful about the y-intercept of a linear regression. Sometimes it doesn't make sense. So since 0 is not part of our data set, the equation may not be good at predicting this value. All right, so we don't really know what this, we know what the y-intercept of the equation is, but we don't really know if that makes sense in the context of our problem. Sometimes if you're like, let's say you measured shoe length and height, and you look at the y-intercept there, well, it doesn't make any sense if height were 0 or shoe length were 0, because those are both, if height's 0, what does that mean about a person, right? There's no person that's ever born or ever exists where the height is exactly 0. That doesn't make any sense. So interpreting it in literally into the context of the word problem may not make sense for your data set. So if you wanted to look at what the scatter plot looks like in a line of regression, remember we stored it in y1, so what we can do is we can go to stat plot, press enter, go to on, the scatter plot's on, my lists are fine right here. I'll go to zoom and then, oops. So, okay, so let me quit out here and then zoom and 9. Right, there's my scatter plot, and it puts the line of regression, because remember that's stored in my y. I asked for it to be stored in my y1, so it puts the line of regression on top of the scatter plot. Okay, and so you can see that 53.64 is my my y-intercept here. Okay, now we're going to use the regression equation in order to do what we called interpolating and extrapolating. So if we want to use the regression equation in order to predict values, so let's say that if a student does 8.5 homework assignments, they did 8 total assignments and then a half of an assignment, what test score would we assume that they would get? Now, we're not going to go back to the scatter plot for this. We're actually just going to go back to line of regression. So what I'm going to do is, since X is our homework done and Y is our original data set, Y is our test score, what we're going to do is we're going to put 8.5 in here for X and find out what Y is. So I'm going to put 8.5 in here plus 17.41. Okay, and the calculator says about 90.34. So if I were rounding to the nearest hundredth, we'd say that they would get a test score of 90.34. Okay, now this is called interpolating because the value that I put in was 8.5, and that's within the data set that we have. So we have numbers that are below and above 8.5. So that's actually called interpolating. Okay. We could also go the other way around. We could have a Y and be asked for the value of X. So how many homework assignments would a student have to complete if they wanted to receive a test score of 90? Well, I guess we've sort of answered that question already, but let's just check that out. So if they wanted 90 to be their Y, what would their X have to be? Okay. So in order to do this, you could subtract 90 minus 17.45. 17.41, okay, and divide this by 8.58, and then we would get about 8.5. So approximately, we need approximately 8.5 here. Okay, so it's approximately 8.46. Remember, these two little squiggly lines means approximately. Oops, I just mean to make two of them. What test score? This is interpolating because using 90 is actually part of what we have for test scores here. Now, if we wanted to figure out a test score for a student who only completed half a homework assignment, this is actually known as extrapolating, because we do not have something as small as 0.5 homework assignments. So it's an X or Y value that's outside of the data set. So in order to do that, we'd have to just put 0.5 in here. Okay. And use the regression equation. Now you have to be careful when you're extrapolating because the values may not make any sense, or not that they don't make any sense, but they may be a little off because it's outside of your data set. Interpolating is a little bit easier than extrapolating. Okay, if you want to find it with a graphing calculator, okay, so the way that we do this here is that we go to mode. So let me turn my calculator on here, and we go to, we go to mode, and we arrow. If you arrow in the upward direction, it sort of scrolls to the back of the different options you have for mode, and you scroll up. This is, by the way, the newest operating system for the graphing calculator for the TI-84. And you go over to stat diagnostics, and if you toggle over to on and press enter, then what's going to happen is when you run a regression, it's going to give you actually more statistical diagnostics than you had before. So quit out of here. Now I've already entered the data into my to list here, so we see L1 and L2. This is from the previous lesson here. So now when I hit stat calc and I go to calculate a linear regression, it's going to give me new information. It's going to give me R squared, which you can use later in another, that R squared tells you something. It's just the square of R. R, though, is what we're going to be really focusing on. R tells us, it now shows this is the correlation coefficient. Okay, so it appears that actually the correlation that we've been working with for the past few lessons, it's actually a pretty strong positive correlation between income and percent ownership. Okay, because the R is equal to 0.88 if you round it to the nearest hundredth, and if we go back to our chart here, 0.88 is going to be in this range, which would be a strong positive relationship. So that means as income increases, the percent car ownership also increases. Okay. Now, to create a residual plot, what you want to do is you want to first put everything in your data, all your data into L1 and L2. So I have L1 and L2 right here. Okay. I actually have the residuals in L3, but I'll show you how to do that later. So once you have that, you want to go to stat and calculate. and calculate your linear regression. So here I have data in L1 and L2, and actually go down and calculate this. Okay, now once you've done that, your calculator actually stores your residuals in one of the lists. It doesn't show it to you. So if you go under second and list, what you'll see is that under 7 you have this list called resid. Those are your residuals. Now to plot those on a stat plot, you go to second stat plot, and I'm following the directions here. Second stat plot, choose plot 1, turn it on, go down to scatter plot, and that's already chosen. Now I have my X list in L1, so L1's okay. I want to overwrite my Y list to make it the residuals. Now to call up the list resid, I'm going to go to second list, okay, that's above stat, and I'm going to choose option 7. Okay, and that overwrites L3 that was in there before with resid. Now my mark, this is the best mark to really use. Then before you hit graph, you want to go to zoom and 9, which is statistics. Okay, and now what it does is it plots those. Now what this line is this is the 0 line. Okay, this is the line that shows x is equal or y is equal to 0. Okay, now what you've done is, so I'm showing the residual plot along with the scatter plot. Okay, so the scatter plot before, I had this x value of 30,000 and a predicted y value of 67.45% car ownership. My actual value was 30,000, and at the $30,000 income level, it was a 55% car ownership. Now the residual plot, when you trace it, so if I hit trace here, what it's going to show me, it's going to show me the difference between the actual predicted value and the actual value. So at 15,000, the difference between the predicted value and the actual value was negative 0.55. That's not a very big difference here. Oh, well, that's the percent car ownership. If I arrow over to 30,000, that's where I get my negative 12.45. So both the value, the x value of 15,000 and the y value of 30,000 have a negative residual. And if we go back to the scatter plot, that makes sense because both of those points are below that line, the regression line. Okay, if I keep tracing over, the income level of 40,000 actually has a predicted value that's less than the actual value. Okay, so that's this right here, this point right here is 40,000. If we look, that point is above the line of regression, so it makes sense that the residual is positive. So anytime the residual is positive here, it will show a predicted value that's less than the actual value. Anytime it's negative, it shows a predicted value that is greater than the actual value because of the way that we take the difference to find the residual. Now the point with the biggest residual is going to appear to be the point furthest away from the residual line, okay, above or below. So the point with the biggest residual is the income level of 70,000. That right there will be shown by the scatter plot to be this point right here. It's the line that's furthest away from the scatter plot, and that's also the point that's furthest away from the residual plot. Okay, so the residuals are a way to tell us how the data, the regression model fits the data. So sometimes we might have a regression model that's not linear, and I'm going to show you what the residuals look like then. So the residuals in this case right here, if the association between the variables are linear, the residual plot looks like a randomly scattered points. Equal points, really not necessarily equal, but there's a lot of points above and below the line. So here, the original scatter plot here is linear, so the points are sort of evenly distributed above and below the line, and the points really are pretty scattered. Like if I were to look at this as a correlation, they would be like no correlation between the distance between the points and the 0 line. Now, the sum of the residuals should be around 0. So if you wanted to figure out what the sum was, you can actually go back to your calculator and you can go to stat, and you can put the residuals in one of your lists. So if you go to Edit, in my L3, I arrowed to the right here. So let me clear this out so I can show you what I did. In my L3, I went above here, and if I arrow down, I'm going to go to L3 and I want to put a bunch, I want to put the residual list into L3. So if I go to second stat, I put 7. So notice what this command says. It says L3 is equal to the residual list resid. If I press enter, oh, so if I press enter, it actually is going to get a problem here, and I realize why. If I hit go to, what's happening is I'm saying that I want one entry to be a list, which was not a good idea. So here, if I want L3, I just have to be highlighting the L3 second list. Okay, I want to go to 7. So here, I want the entire list L3 to be the residual list. Okay, and this should work here. All right, now it put all the residual list, all the residuals in here. Now, if I want equal points above and below the line, that means that some are going to be negative and some are going to be positive. So they should really be, the sum of them should be near 0. Okay, so if I want to sum up all the things in this list, what I would do is I would go to second list. Now, names is the first tab here. If I go to arrow to the right, I go to math. This is all the math that you can do on your list. So if I choose option 5, oh, actually, you know what? I need to be in my home screen here. So if I go to second list and I choose math here, and I choose option 5, I want to sum, and I want to tell the calculator that I want to sum L3, which is our residual list. So L3 is here. I actually didn't need to put residuals in L3. I could have just left it as resid and asked it to sum that. But okay, so it's -2 times 10 to the -12. Think about how small that is. That's negative 0.0000. There's 11 zeros, right? And then a 2. So that's actually very close to 0. So that indicates that the line that we had is a pretty good fit with the data. It indicates that the residuals are almost summing to 0, so the line of regression is a pretty good fit. Now, the sum of the list doesn't, the residual list doesn't always tell you that if it's equal to 0, it doesn't always tell you that the line is the best fit. But when you already know that it's a linear association by looking at the scatter plots here, or the residual plots here, then you can use the sum to sort of verify that it's a good fit.